Good morning all. I am Sneha Sanap. Now I am presenting my PPT. Now I am sharing my screen with you. Welcome to all. I am Sneha Dinkar Sanap. Uh, I have completed my MSc in Physics in Bambu University. Now I am pursuing PhD in our Bambu University under the guidance of Professor Dr. Mitkari Shivanshkar Ramlinga sir. He is the head of the Department of Physics from Siddheshwar Mahavidyalaya, Jalgaon, District B. My topic name is study of attenuation of water, study of attenuation of coefficient of water soluble organic and inorganic compounds at different energy level. So, everyone, good afternoon. Today I will be presenting a study on the attenuation of coefficient of water soluble organic and inorganic compounds at different energy levels. This energy is curriculum for various fields, including the environmental monitoring, medical physics, and nuclear physics. This study is very important in nowadays in nuclear physics and astrophysics also in our medical side also, and even in pharmacy also, and in farming also. All this is very important, this topic. By the understanding how these compounds interact with the radiation at different energy, we develop better methods for water treatment, radiation theory, and radiation shielding. Okay. Now, the attenuation of coefficient of water describe the how to intensity of X-rays for gamma. It is decreases or increases and passing through the material. It is a circular for understanding how to different material for a different absorbing and scattering radiation also. Okay, so what is attenuation coefficient? The attenuation coefficient is denoted by the symbol of mu, is the hero of our story. Okay, so we can say this in whole process only attenuation coefficient. The basically we are denoted by the mu symbol, and it is a we can say a hero of the stories. Without attenuation coefficient, we can't develop our study, and we can go ahead without this attenuation process. So attenuation process means any rays is thundering on the any material and how it is passes means and it again reflected. It is known as actually attenuation in a simple and easy languages. The higher attenuation of coefficient, the more efficiency is the material weakness of the uh, radiation beam. Okay. So the unit of the attenuation coefficient, we are reciprocal centimeter. So here an analogy, think of the like friction coefficient between the shows around the higher refraction coefficient of means more stopping power of this attenuation. So maybe we have that law to use in this whole process, that is a Beer-Lambert's law, and we are very beautifully capturing this relation between the initial final radiation intensity is the material thickness and attenuation coefficient. In these equation allows to calculate attenuation coefficient based on their measurable quantities. So in this attenuation, uh, we are expressed by units of a centimeter reciprocal. So in this whole process, we have to use maximum time to express the attenuation by using the means attenuation means mu, which we are denoted in mu. How to express it? So unit is a centimeter reciprocal. Water is soluble unbiotic solvent, and understanding how to dissolve compound at radiation and attenuation importance. So this studies investigate the different attenuation coefficient of various water soluble organic and inorganic compounds across a range of energy levels. So basically, we know the where we use the attenuation coefficient. That is very it is very important for in our daily life, not even in our daily life. So even even also in our wars. Basically, nowadays we are also hearing about the wars and how to prevent ourselves by the using of attenuation of coefficient. We can also prevent ourselves. The attenuation coefficient is a virtual parameters in understanding how radiation interacts the matter. It tells us how much intensity of radiation decreases the travel through the material. Water is a significant compounds of living organism and environment. Okay. Therefore, the studying how dissolve the substance in water and affect the radiation attenuation is circle of various application. In this presentation, we explore the attenuation of coefficient of a different water soluble organic and inorganic compounds at a different radiation and different that levels. Factors affecting attenuation. So we have to find out how the all factors is affecting an attenuation. Actually, survival factors influences the attenuation of radiation by a material. Material is a conception material with the higher atomic numbers generally have the stronger attenuation coefficient due to their greater electron density. Imagine a shield made of lead atoms and various one made of hydrogen atoms. Long and low atomic number. So when we are taking a different type of a soil sample, otherwise some salt, sugar, this type of materials, and which have a low atomic number. So we can take it and we can consider on that attenuation on that material, and we will get the exact coefficient of that. Is that attenuation coefficient soluble organic and inorganic compounds. The lead shelled we much more effective stopping radiation because its atoms have more electron to interact with the radiation. Okay, so radiation is the typical different type of radiation. We know the X-rays and we know the Y rays also, and gamma rays also, and neutrons also interact with the matter differently, leading to various and interaction of coefficient radiation energy. The attenuation coefficient often the inhabits actually the energy independence for the contents materials and different radiation type interaction coefficient of coefficient of water. Basically, the way of material weakness and radiation depend upon the survival factor. That is a material make you place to a circle role and materials compounds elements with the higher atomic number, meaning denser elements with the more protons and electrons tends have the stronger attenuation of coefficient. This is because they have a more electrons available interact with the absorb the radiation. The type of radiation of also is the matters. Okay, X-ray and gamma ray both are differently with the matter compounds and electrons leading the different attenuation coefficient for such radiation type of final and with the energy is the itself. Radiation shielding. Basically, radiation shielding is the uh, per amount, and radiation shielding plays a virtual role in protecting the harmful effects on ionizing radiation. This presentation will be explore the concept of the radiation shielding, its application, and material used to uh, retract effective shielding. By understanding the principle, we ensure the safe use of radiation, various fields from medicine and nuclear physics. In nuclear power and nuclear physics, this radiation and shielding is very important. How to protect ourselves and how to protect our other things means material. Uh, when we are using this attenuation of coefficient, it is very useful in war. Actually, I tell that things the sheltering material we achieve this is interactive with the radiation through observation and scattering. Okay, and the observation is what? Radiation energy is taken by the sheltering material and convert into the forms of energy like heat. Okay, scattering is also the part of the radiation and it is deflected to the original path of the interacting with the atoms in the shell. Reducing it is the ability to present future. Why radiation shielding is important? Okay. So in basically, we are using this radiation shielding, and we are also asking why it is important in our life. So it is important in our life just because of ionizing radiation can damage living tissues and cells, potentially leading to health and problems like radiation, skins and skin cancer. So we have to shielding that radiation by using this attenuation. So radiation shielding is essentially various application for protect people and their environment, environment also. Okay, so that is very harmful, so we have to protect ourselves to using a shielding, is that so medical images, x-rays and ct scan shielding protect the patients and staff from unnecessary radiation exposure during the medical process. So we are going to a in hospital to check out the x-rays and virus, otherwise a ct scan, so we are also protect our body from that shielding materials. Okay, nuclear power plants shielding significant works and the environment from the radiation related during the nuclear reactions. Industrial radiology shielding ensures the safe use of radiation for inspecting wheels and materials industrial scattering. So research facilities and research shielding is also the process of the radiation radioactive materials. Type of radiation and shielding is they have a lot of types, and so basically I tell you the some small and it is very useful types of radiation and shielding. The selection of shielding material depends on the type of energy of the radiation. So it is depend on which type of material we are using to a radiation. So on that type we are also shielding that material. So lead is highly effective material to block the gamma rays and X-rays into the high atomic number and definition density. Con Concert, a wide used shielding material for the cost-effective and ability to attenuation broad range of the radiation types. Still, steel is there, water is there, and diplomatic uranium is there. Experimental method are there. So we are taking the one wall or material, any kind of a material we can take it, and we are using also some thick material in that, and we are using a beard Lambus law, and now we are rendering some rays on that material, and only some rays are passing that material. So it is depend upon that thickness. We are using that formula: initial intensity of radiation, transmitted intensity of radiation, and thickness of the sample. So here is a one big thickness of the sample, but only some material can pass straight, and some are going in different direction. So we can say the thickness of the gamma rays, thickness of the sample, and attenuation. Attenuation is what with that material is not going in a that typical way. It is passing in a different direction. That is actually attenuation. So we are using this experimental method to um, to recognize and to understand the attenuation process. So some of time we are choosing the organic compounds to pass the attenuation. Okay, so organic compounds generally inhibited lower attenuation coefficient compound to organic compounds. The attenuation coefficient organic compounds often showed the minimum depend on the different energy. These trends can be attributed the lower electron density and simpler atomic structure of the method organic molecules. Okay, so organic compounds and these inorganic compounds have a different type of atomic number, and different type of atomic number is also effect on a different type of energy level. So our finding related the organic compound generally display and lower attenuation coefficient compound to organic compounds. Additionally, with the attenuation coefficient of compounds obtain the inhabited manual variation across the range of energy level study. So in this manner, we are using this attenuation of coefficient of water. Is this all compounds, which is very organic? Organic means sugar and salt is also there. So these organic compounds is affect on the attenuation coefficient of water or not. We are find out that only. So glucose is there, benzenic acid is there, sugar is there, sodium and carbohydrate is there, absorbing sodium, sodium hydroxide, citric acid, polyethylene glucose, and urea. So there is a lot of organic compounds we are using to find out it is soluble or not soluble in water. And inorganic compound, that is also a typical type of displaced higher attenuation coefficient that in the organic compounds. The attenuation coefficient of inorganic compounds often in exhibited a greater depend on the energy level. So each and every attenuation of coefficient of water and inorganic and organic compounds also have a different energy levels. So in that different energy level, we have to find out the atomic number of that energy level to using the coefficient of water. So there is we are using a sodium carbohydrate, sodium chloride, sodium uh, ferric acid, magnesium nitrate, and nickel nitrate, nickel uh, copper nitrate also. So this use of high energy ionizing radiation, especially gamma ray, is rapidly growing in many sectors like nuclear reactors, industries, medical diagnostic, nuclear researchers, food interaction, and we can say though we have when we have to prevent our food in fridge, that time we are also using a attenuation of coefficient and nuclear waste strong storage sites. Okay, in biological studies, we are also in that CT scan also, X-ray also. We are using this attenuation. Defects defecting in a material casting, medical images and therapy. Space exploring in our space, we are using this the gamma rays and X-rays factor so much to find out the some experiment and all this in and high energy physics experiment as soon. Okay, so exploring with the board investigation. Uh, we are choosing this type of compounds and different type of material and we are find out our plants and I mentioned here so my some experimental step and some study and how I am going with these studies. So now literature survey I did literature survey that I explained and that I make some PPT here. So literature survey means which books we are preparing for that and we are taking under the guidance of Shivanshwar sir also and Dr. Pravina madam also. We are going ahead to investigate this and we are making some analysis. And after that, some steps of investigation, the data analysis and how to experiment. We are using the scattering counter and satellite counter and PC based 8K MCA for the calculation. And we are taking the some foil paper also, some coins also, and some different materials also. And we are using that material and making some papers and writing this thesis. So it is very experimental and interesting topic to go ahead for our each and every field that space or biological also medical also and also our food our body to prevent how from the accident virus also. The experiment set up for the measurement attenuation coefficient by using satellation counter. This one is the image of satellation counter which is available in our Bambu University in our physics department. So we can use this satellation counter. This is also connected with the MCA 8K MCA PC and it have an ampere and have a high power resistor. So detector is there, symbols is there. We have to take that coil and putting some compounds and giving some rays of that at your standardization, and we will find out the our result. Okay, so basically here is the some picture of that machine. And this mass attenuation coefficient of the selected samples were measured experimental at photon energy of radioisotopes. So when I search out or when I find out, so I got this different type of atomic number with different type of energy level. So I share with you the different type of energy level, different type of strength, and the half life of that strength is that only colloid bond, necklace, calcium, magnesium, uh, and it have a different type of atomic number, and this is the what this is our scintillation counter and pc also. So we are using this formula I upon our experimental use, and these the linear attenuation coefficient values of the selected samples are determined by the following relationship. So thank you for giving me this great opportunity to with you. Thanks to all.